answer is positive or negative in that little symbol, you have to end up with a positive answer. So the absolute value of 10 is equal to the absolute value of negative 10, which just equals 10. Now, why did I do that? I did that because maybe someone's going to start at point A, which is 3, and go to point B, 13, and take 3 minus 13. And somebody else is going to go from B to A, right? That's why I want you to think about that. You're still going to get the same distance, whether you go east and west or west and east, right? North, south, east, north, south, north, whatever. So what is the midpoint? How do you know what the midpoint is? Well, if we know how far apart they are, divide it by 2. So I'm going to take the 10 and I'm going to divide it by 2. And that gives me the number 5. What does that mean in terms of my little grid up there? It's how far. This tells me that it's 5 units from the ends, from each end. So let's see, 1, 2, 3, 4, 5 from A, 1, 2, 3, 4, 5 from B. Oh my goodness, it is right here. So that helps when I have a number line. But what if I didn't have a number line? Well, much like what we just did with the midpoints for an ordered pair, let's find the average. Let's find the average of the 2 points. Instead of thinking about how long that segment is, let's find the average. And average is you add up so many digits and then you divide by the number that you add up. So if I add up the 2 digits, 3 and 13, average means I have to divide. How many digits am I dividing by? 2. I'm going to divide by 2. Well, what is 3 plus 13? 16. And 16 divided by 2 is, oh my gosh. So this is the midpoint. This actually is the midpoint. So what do you notice about the average of the 2 endpoints? It is the midpoint. It doesn't tell you how far away it is from each endpoint. It tells you exactly what the midpoint is. Okay? Which is what we just did when we did the midpoint from the ordered pairs. So that's what we're going to do next. So segment AB, point A, 2, 3, and B, 14, 11, they're already plotted for us. And we're going to find the average of the X and the Y coordinates of the endpoints. So what does that mean when I say we're going to find the average of the X and the Y's? Emmanuel, pick your head up, please. Pick your head. What does it mean when I say we're going to find the average of the X and the Y coordinates? What is average? The middle. So how do I find the middle? What did we do in example C? We're going to take the 2 X coordinates, or what did we just do in our journal? We take X1 and X2, we add them and then divide by. That's exactly what we're going to do. So the first thing I want to do is label this X1, Y1, X2, Y2. So I'm going to add my X1 and my X2 coordinate and divide by 2. And I'm going to add my Y1 and my Y2 coordinate and divide by 2. This is how I find the midpoint. Okay. So let's see. 2 plus 14 divided by 2. And 3 plus 11 divided by 2. What is 2 plus 14? 16 divided by 2. 8. Emmanuel, do you need to go downstairs? You need a snack? What is 3 plus 11 divided by 2 is? So that's your midpoint. It tells us to call this C. I want everyone to call that point C, and I want you to graph it. Call it point C, and I want you to graph it. So I'm going to graph that point 8, 7. Hey, Miss Leslie, how are you doing? So 8, 7, and I'm going to call it point C. Leslie, grab a pen. Actually, we'll give you a journal in a minute. We're just now starting page 27 notes. So give an argument for why C must be the midpoint. How do we know C must be the midpoint? It's what? Yeah. How could I prove that it's in between exactly in the middle of A and B? Huh? I could find the distance between both sides, yeah. Or I could use, what am I drawing here? Could I use Pythagorean theorem? Let's see, 1, 2, 3, 4, 5, 6. This is 6. 1, 2, 3, 4. So if this is 6 and 4, if they're exactly the same apart, what should this be? It should be 6 and 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So here's what I'm going to say. 6 squared plus 4 squared equals C squared. We're going to call this D. And 6 squared plus 4 squared equals D squared. C squared, if these two things are the same, that means that C squared has to equal D squared. Am I losing you guys or am I making sense? Okay. I lost you? Okay. Who said that? So do you see that I labeled this C, not point C here, but C as in like a hypotenuse? So I have this triangle that is 6 by 4 the legs. So 6 squared plus 4 squared equals this hypotenuse. And then this triangle right here has legs 6 and 4. So this 6 squared plus 4 squared equals D squared. I just set up two triangles. Do you guys see that? And because these numbers are exactly the same, that means that this has to equal this. But if I want to get C all by itself, I unsquare it. And that means that C equals D. And that's actually a math proof. Like you just proved it using math. Okay, so that's your argument or your proof. Now we could have done the distance formula, but I want you to remember Pythagorean theorem because sometimes it makes things much easier. Flip it over, page 28. Flip over to page 28. So in page 28, this is where it introduces the distance formula or the midpoint formula. It says, hey, guess what? If x1, y1, x sub 2, y sub 2 are the two endpoints of a line segment, then the midpoint lies at the average coordinates of the two endpoints. The midpoint is the average of the coordinates. So we're going to find the midpoints and we're going to break this up a little bit. So if I break the room up diagonally again, so from me to the door, I can cut a diagonal line. So that means everyone at Leslie's table, Max's table, Gerardo's table, Lainey's table, and Braden's table is going to do A and B. Everyone at Nate, Luce, Isabel, Emmanuel, and Jaden's table is going to do C and D. So one half of the room is going to do A, B. The other half of the room is going to do C, D. I'm going to freeze the screen and do them all, and then we'll catch back up. So you're just finding the midpoint. In a few minutes, as soon as I'm done with this. Did you finish your tests, your quizzes? Okay. Are you calculating one of these? It's not that hard. Look at the formula up there. Come on, you guys. How are we doing? We about ready? All right, A. So for A, 9 plus 13 is 22. 22 over 2 is 11. 3 plus 7 is 10. 10 divided by 2 is 5. So the first midpoint is 11, 5. The second midpoint, negative 1, 10. The third midpoint, negative 3, 6. The fourth midpoint, 5.5 and negative 7. 5.5 and negative 7. Does the line whose equation is y equals 5x minus 32 bisect point EF? So let's talk about what bisect means. Bisect means cut into two equal parts. So if that line cuts segment EF into two equal parts, it means it goes through the midpoint of EF. So we need to find the midpoint of EF and then see if that ordered pair works for the equation. So how do I find the midpoint of EF? X1 plus X2, 4 plus 8, divided by 2, comma, 3 plus negative 7, divided by 2. 4 plus 8 is? Anyone? 12 divided by 2 is? 3 minus 7 is? Negative 4. Manuel, pick your head up. Negative 4 divided by 2 is? Negative 2. So this is the midpoint of segment EF. It's the midpoint of the segment. If this line bisects this segment, then it's going to cross right here. That means that this equation, this ordered pair makes this equation true. So I'm going to write this equation, y equals 5x minus 32. And I'm going to let x equal 6. And I'm going to let y equal negative 2. So let's see, does negative 2 equal 30 minus 32? Yeah, because that's negative 2 equals negative 2. We're almost done. Our last example asks us to find the midpoint of segment PQ. Someone walk me through how we're going to do that. How are we going to find the midpoint of segment PQ? So tell me what to write. What are the numbers I'm adding together to find the average of? Negative 3 plus 5, okay? And negative 4 plus 8. Dividing them both by 2, yeah. What is negative 3 plus 5? So that's 2 over 2. And what is negative 4 plus 8? 4. What does 2 over 2 reduce to? What does 4 over 2 reduce to? So the midpoint of segment PQ is the ordered pair 1, 2. Find the slope of segment PQ. How do I do that? Well, I can count it, or I can use the slope formula, which is y2, 8, minus y1, positive 4, plus 4, over x2, 5, minus a negative 3, which equals 12 over 8. Can I reduce my slope? These are both divisible by 4.
Yes.
It's 3 over 2. Yeah, and you could have just counted. If I go from here to here, how much do I go up? 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Do you guys see that? So you can also count your slope. So you know you have a slope of 3/2. So it asks me to draw the perpendicular bisector. Well, bisect is the midpoint, but what does perpendicular mean? What do we know about slopes? Huh? What do we know about perpendicular slopes? It does form a right angle. And so if I know the slope of this line is 3, 2, if the slope of PQ is 3 over 2, what does the perpendicular slope have to be? Negative 2 over 3. Good job. So this point is what? It's the ordered pair 1, 2. So write an equation, it says, in point slope form. How do I write an equation in point slope form when I know the slope and I know the ordered pair? I know the slope and I know the ordered pair. What is my slope? It's written right there. M perpendicular is what? Okay, so there's my slope, negative 2 over 3, and the point is 1, comma 2. What's point slope form? Andre's here. Point slope form, what? Y minus the y1 coordinate equals my slope times x minus the x1 coordinates. So I'm going to start at this point and I'm going to go down 2 over 1, 2, 3, plot a point. Down 1, 2 over 1, 2, 3, plot another point. Down 1, 2 over 1, 2, 3, plot another point. So the perpendicular bisector is this line right here. Yeah. Oh, yeah, it is. Sorry. Thank you. It's still going to, yes, sorry. So it's not going to change your line. So question D, part D of this says, pick a point somewhere on your line that you drew that is not point M and label it as R. So I'm going to pick this point right here and I'm going to call it R. That is the ordered pair 6, 7, negative 2. This is the ordered pair 7, negative 2. So R equals 7, negative 2. I picked a different point on your filled out notes. So what is the distance from R to P? How do I find that? What do I have to use? The distance formula, right? So P is the ordered pair negative 3, negative 4. So the distance from R to P, well, that's negative 3 minus 7 squared plus negative 4 plus 2 minus a negative makes it a positive. So negative 3 minus 7 is negative 10 squared. Negative 4 plus 2 is negative 2 squared. That gives me 104. That's my distance. The square root of 104. I'm going to leave it just like that because I just want to show that these two distances are the same. So now I'm going to check the distance from R to Q. That's this line right here. So let's take a look at that. Point Q is the ordered pair 5, 8. So the distance 5 minus 7, the quantity squared, plus 8 minus a negative gives me a positive 2, the quantity squared. Let's see, what is 5 minus 7? Negative 2 squared, plus what's 8 plus 2? 10 squared. Negative 2 squared is 4, plus 100 is 104. So what's your observation? Well, the distances are the same, and triangle PQR is what kind of a triangle? It's isosceles. Triangle PQR